Here's our third video for using substitution to solve a system of equations. The first video, both equations had a variable, the same variable that was isolated. Our second video had one variable isolated, and now in this third video, we won't have any of the variables isolated. So looking at number 13, 4x minus 7y equals negative 4, and x minus 4y equals negative 1. I don't have the ability to substitute just yet. But what I want to look at is the constants in front of each variable. So in front of this x would be a 1. And my goal here is going to be to isolate a variable. I can choose any of the 4 variables I want. The first x, first y, second y, it doesn't really matter. But what the easiest one will always be is the one with a constant of 1 in front of it. Okay, it'll create one less step for you. So what I'm going to choose here is I'm going to isolate this x in that second equation. So x minus 4y is equal to negative 1. And it's just one simple step. And now I have x isolated. Okay, so x would be equal to negative 1 plus 4y. Now that I've isolated that, so this is my work for isolating. Now that I've isolated that, I can take that x equals negative 1 plus 4y and substitute that in for my x value in the other equation. Okay, don't choose the one that it came from because everything will just cancel out. So I'm going to take 4x minus 7y is equal to negative 4, and I'm going to substitute in for my x value. So we have 4, negative 1 plus 4y minus 7y is equal to negative 4. And now, unlike the last videos, we're just going to solve for our variable. Negative 4 plus 16y minus 7y equals negative 4. I'm going to combine like terms here, get 9y. Add 4 to each side, so 9y equals 0, divide by 9, and y would be equal to 0. So that's the first part of our answer. And what I'm going to do is take that y equals 0, and I have the choice. I can plug it in here, here, or I can even plug it into the new variable that a new equation that I've created. And what you'll find is that it's going to be easiest to plug it into that new equation. So I have x is equal to negative 1 plus 4y, and I'm going to plug in for that y variable. Again, it's always easiest to substitute in for an equation that one of the variables is already isolated. Because now I need to just simplify one side of the equation, and I'll have my solution. So negative 1, 0 would be my coordinate point where these two intersect. Taking a look at 14, this first term, this x here, that is the one that I want to isolate. So I'm going to do x plus 2y equals 16. Again, the constant is 1. If I chose a different one, so say I wanted to isolate the y in this case, I would need to move the x and the 2. So to avoid that extra step, I'm just going to isolate the x. It's not wrong to do it the other way, it's just going to be more work. So this is my isolate. And now I can take that where this x is equal to 16 minus 2y, and I'm going to plug it in for my x value. So negative 5x plus 7y is equal to negative 12. And we're plugging in for x. So negative 5 times 16 minus 2y plus 7y equals negative 12. And now I can solve for y. So negative 5 times 16 is going to be negative 80 plus 10y plus 7y is equal to negative 12. Combine our like terms, so we get 17y. Let's add 80 to each side. 17y equals 68. And if I divide by 17, I should get y is equal to 4. 17, yeah. Y would be equal to 4 here. So when we take that, let's change colors. I'm going to take that y equals 4. And once again, I have the choice of plugging it into any of these 3 equations. I'm going to choose the one where x is already isolated. So x is equal to 16 minus 8, so x is equal to 8. And then my coordinate point would be 8, 4. Make sure you write the x value first and then the y value. So you'll find moving forward in these problems, you're always trying to isolate the variable. So if I look at 16, isolate, in this case, I would isolate x. 17, I would actually isolate y, because that coefficient is 1. Now, you may ask yourself, all right, what happens if I have something like 3x plus 4y equals 10, and 8x minus 6y is equal to 4? Well, you have the choice. You can isolate something with extra steps, but you're going to wind up with fractions here. Something like this we're going to cover in a future video where we look at the elimination method. All right, and the elimination method will become far more useful when substitution doesn't really apply. All right, you could use substitution to this system in red here, but it's going to be easier to use the elimination method, and we'll get to that in the next series of videos.